Hello dear students, I'm glad to meet you at our course. Today we are going to study factors to consider before building a long-span structure. Let's start. While the most architectural terms are cut and dried, long-span is more subjective, and the definition is a building or other structure that spans a long area. By general consensus, long-span structures are at least 20 meters. The advantage of long-span buildings is that there is more space inside. Long-span buildings are popular for sports arenas and other applications requiring maximum visibility, and for bulk storage and retail uses requiring a large clear area. Due to the nature of long-span construction, the construction materials, including framing members and trusses, are oversized and require special care for installation. Long-span structures may need bracing during craning and construction to keep the materials true. Before constructing a long-span structure, make sure the contractor and building installation crews have experience working with buildings of a similar size. A licensed engineer should also be consulted in the planning stages of a long-span structure. The engineer will ensure that the building meets local building codes. Designing long-span structures requires an obsession with stability. Certainly, the structure has to hold up its own weight. Just to span the required distance, a structure has to support the significant dead load. But the complexity of a long-span design increases exponentially when snow load, wind load, seismic load, deflection, serviceability, and the dead weight of the floor or roof system are all factored in. Architectural appeal drives the design of such structures, but many factors, working simultaneously and in varying degrees, must be analyzed in long-span design. In these cases, an architect is typically a part of the team designing the building. The challenge in developing a long-span design is to integrate the architectural concept and appeal with the most efficient, purest structural system. Relevant questions include: what are the site constraints? Should the pieces be pre-assembled or must the structure be stick-built? What type of temporary support is needed? What is the nature of the field connections? What is the inherent stability of the elements during assembly? How will differential deflection impact the structure? How can load be transferred from temporary shores to the permanent structure? Perhaps the greatest challenge is creating a model of the structure that describes how loads change in an as-constructed sequence. Typically, structural models are developed assuming a zero-gravity system, i.e., they assume a 100% constructed structure prior to any load application. In reality, the structure is built one piece or assembly at a time, and the load path for the dead loads may vary significantly from that assumed in the structural design model. In addition, when and how the structure is temporarily braced, it creates different gravity and lateral load paths. By addressing the various load paths as the structure is being constructed, the engineer can adjust the design for erection too, not just the final state. By considering the load paths and how the structure responds as it is being constructed, the engineer is able to develop designs that facilitate the sequencing of construction and allow efficient use of temporary shoring. Addressing instability issues that occur during construction impacts member size, temporary shoring requirements, and construction sequencing, all of which have a significant impact on overall project cost and schedule. Certain construction materials are better suited for long-span structures. Long-span structures must be made of materials light enough not to require interior support, yet sturdy enough to withstand the pressures placed on the structure. Steel is a common building material for long-span structures. Steel is strong and relatively lightweight, so it is suitable for the building frame and/or the outside cladding. Wood, particularly wooden trusses, may be used for smaller long-span buildings. Long wooden beams are more expensive and harder to locate, so wood is less common for larger buildings. Structural fabric is a common choice for long-span structures because fabric structures are lightweight, inexpensive, and can quickly cover large surfaces. Many long-span structures, such as the Munich Olympic Stadium, use fabric to create eye-catching shapes not available with other materials. Glass curtain walls on non-load-bearing walls provide a unique appearance and unite the inside and outside of the building. There are a few important construction aspects to consider while building long-span structure-based bridges. Choosing the most appropriate method of erection. The choice of the method depends largely on the type of landscape, the depth of water bodies involved, and the distance to be covered. The type of foundation. This generally depends on the geotechnical condition of the region as well as environmental factors, such as the maximum wind speed and air pressure at the highest point. The need for the construction of substructures. This can help to minimize the construction cost and time in a considerable manner besides enhancing the quality of the structure and workplace safety. The use of the right tools and technology. Since constructing bridges is quite unlike construction buildings and other structures, the tools and techniques used here differ significantly and play a vital role in ensuring the safety and long life of the structure. It is also important to consider the geographical and environmental factors during bridge construction. This might include the presence of an older structure or the need to maintain the delicate ecological balance of a specific region or any other issues that need to be cleared with the proper authorities. Long-span structure construction is a lengthy process. Before embarking on a long-span construction process, be sure that you are using the right materials and the right installation team. Thank you for your attention, dear students. Next time we are going to study tall buildings, past and present trends. See you next time. Goodbye.